Noli, the head monster here, and we are here at the Monster Cable HDMI Test Laboratory. I'd like to talk to you today a little bit about HDMI cables, maybe clear up some of the confusion about HDMI, and then look at the performance of some of the various HDMI cables that are out there. So before I get into the actual measurements, let me talk to you about what we mean and what we're trying to measure in speed of the cable. So you can imagine the cable is like a pipe, and some pipes are this big and some pipes are that big. And we also look at the flow of the data through the pipe. That flow is measured in gigabits per second. So let me give you an example. When we had the normal DVD player that went from 480i to 480p, that is not high definition as we know it, and in fact the data rate is very low. It is less than 1 gigabit per second, precisely 810 megabits. So what do we mean by high definition? Well, high definition starts at 720p/1080i. And for this purpose, we're going to talk only about P. Well, that rates at 2.2 gigabits per second. But remember, we're only talking about the total throughput of the cable. There's actually 3 conductors in there. So when we measure each conductor, that is about 740 megabits per second, less than 1 gigabit. But the total is 2.2. Then we jump up into what is currently the state of the art. That's PlayStation 3, that's Blu-ray DVD, that's 1080p, twice the data rate, and from 8-bit color to 12-bit color, and at 60 hertz per second, refreshing that data 60 times per second. That goes up to a 2.2 gigabit per second per lane, for a total of 6.68 gigabits in that big pipe. That is a lot of data, folks. But that's not where it's going to stop. By the end of this year, we're going to see refresh rates of 120 hertz. That is twice of what 60 hertz is. So a 1080p 8-bit color at 120 hertz, we're talking about 8.91 gigabits per second total. But here's where we're going to test. Monster makes high performance cables. We want to make sure that we're not only ready for all of the technology today, but what is the technology going to be tomorrow? How big is that pipe? In fact, you might know in Ethernet cables we had category 1, category 3, category 5, category 6, and now they're talking about category 7 cables. It never stops. So we want to make sure that the HDMI cables that you buy today will take advantage of those technologies tomorrow. But what is that technology? Well, we nailed it at 1080p, 12-bit color, as is available in a PlayStation, at 120 hertz, and that is a whopping 13.36 gigabits per second. And per lane, it is at 4.45 gigabits. And you'll see us doing measurements as that as a starting point for higher performance in the future. But does it stop there? No. You already have more than 1080p displays in service now through your computer screen. You have something called a 1440p. That is more pixels, 12-bit color at 120 hertz refresh rates. You can get that out of some video cards today. That is a whopping 25 gigabits per second, 8.5 gigabits per lane. We're not going to test quite that far. We're going to take it up to 7 gigabits per second per lane, up to 21 gigabit cable, and that is huge. That's a huge amount of data that we're trying to put through all of these different cables. So if you're looking for low performance, don't look here. If you're looking for high performance, that's where Monster excels. So we're going to take a look at some of the different cables now that you understand the size of pipe and we're going to take a look at some of the pipes that are available today and how we're going to actually fill them. So what I'm about to show you is a direct relationship between the amount of water we're trying to put down that pipe in gigabits per second, the resulting resolution of what we call the eye pattern test, and how it's affected by length. Now you can imagine, if you're trying to push a lot of water down a long pipe, it takes a lot more force to do it. And the longer the pipe, the less water is going to get through. So you got a really good analogy of what you're about to see, but now you're going to see it in terms of data rate and picture quality. First, there are many different ways to rate an HDMI cable. The most conclusive is what they call the eye pattern test, and we're going to be talking about that particular test, and that is going to be the main focus of what we show here. Here's a close-up of the eye pattern test. This is what we call the mask. This here is called the bit waveform, and the idea is to keep that bit waveform very thin. And when you have distortions in that waveform where the data starts to smear because of jitter, this waveform will start to get bigger and start to interfere with that mask. Also, you'll see where the cable resistance starts to bring down these bit waveforms to where they start to intersect with the mask and hit it. When it hits, that's a failure in that particular cable. So there it is, the perfect eye pattern test. Let's see how our different cables do. The first cable I'm going to show you is our highest performance cable. This has the highest throughput, the biggest pipe of any HDMI cable in the world. And to prove that to you, first we're going to take a high performance signal. As I said, Monster doesn't rate for low performance, we rate for high performance, which is why we're going to start with a 4.45 gigabit per second signal. So here's the cable in a 2-meter length. Go ahead, Leo, and plug that in, and we'll run that eye pattern test. And as Leo's plugging that in, the eye pattern test will take about 2 minutes. And if you can zero in on the scope, you'll see the eye pattern start to build up slowly. Now, as I said, the length will determine how clear that eye pattern is. It will be no more clear than in 2 meters. That's the shortest length. The optimum length that we'd like to test is 4 meters. 4 meters being about 12, 13 feet. Now I know that many of us who use flat screen TVs will run 25, 30, and 50 feet. More on that in a little bit. But you can see here, if you can zoom in on this scope, you can see that the eye pattern beginning to fill in. These little dots that are happening, each one of them represent a test many times a second. And as this thing tests, you'll be able to get an idea of how that eye pattern is forming at 4.45 gigabits. So let's give it a few more minutes. Boom, there it is. And you can see here that we've got a very symmetrical bit waveform. We've also got the mask, the data not hitting that waveform at all. So I would say at this extremely high data rate, at 2 meters, at this extremely high data rate at 2 meters, that's excellent performance. I wonder what it'll be at even